Hi GOR, this is Unit 4, Lesson 1, and we're going to talk about dilations today. This first lesson, we're going to do dilations off the coordinate plane, and tomorrow we will do them on the coordinate plane, and they're a little bit easier. But first, just what is a dilation? A dilation is a rule that moves points, so it's a rule that moves points a specific distance along a ray. It's a rule that moves points a specific distance along a ray. Basically, we are making things bigger or smaller. The notation that we use for dilation is a capital D. All right, lots of times they'll put an O there because you're going to always dilate from the origin. And K right there is my scale factor. So a dilation is a rule that moves points a specific distance along a ray. We're either making it bigger or making it smaller. A dilation, this is important, a dilation is not a rigid motion. Because to be a rigid motion, the length and the angle measure have to be preserved. With a dilation, the angles will be preserved, but the length is not preserved. The image is not necessarily the same size as the pre-image, and rigid motions preserve length. So that frequently is a nice, easy Regents question that they put in there, but a dilation is not a rigid motion. So I have two pictures right here of some dilations. So the pre-image is always the original. So I have the one on the left labeled, and that's the one that has ABC, no primes, okay? That's my pre-image right there. O is the point that I'm dilating it from, okay? And we can see that the distance from O to A is, they call it lowercase a, and the distance from O to A prime is out here. That's twice as big. The image is what it became, and I use the same letters but with primes. A prime, B prime, C prime. And look at the sides. This side was 4 and now it's 8. This side was 5 and now it's 2. This side was 3 and now this side is 6. You can see that it got twice as big. So this is a dilation that got bigger. My scale factor, okay, well that's the scale factor is going to be image over pre-image. So this is a dilation where it gets bigger. My scale factor is greater than 1. And I can actually figure out my scale factor because I have some numbers on the side. The way I figure out my scale factor is it's image over pre-image. So my scale factor, the image is what it became. You can just take any one of these sides, 10, and put it over the pre-image, 5. My scale factor is 2. The scale factor is the same for all the sides. Take the other side, 6 and 3, which is 2. Or take the other two sides, 8 and 4. All the sides have the same exact scale factor. Now this one on the right, I don't have it labeled as much, but it's getting smaller. How do I know it's getting smaller? Because this right here is the pre-image, that's the original, and the one with the primes is my image. Okay, so it gets smaller. The only way I can get smaller is if my scale factor is a number that is between 0 and 1. So it gets smaller, and I have that written down below as well. But the scale factor, if it gets smaller, that scale factor is going to be a fraction, a number that is less than 1 but greater than 0. All right? This is important. Dilations create similar figures. The figures will be similar. They'll be the same shape, but not necessarily the same size. All right. So let's look at these three cases that I have here. Case 1 is an enlargement, and see how my scale factor is greater than 1? And my definition said it's a rule that moves points along a ray. So this is my ray. So this is how far P, this is my original point. That's how far away it is from the center of rotation, of dilation. And then P prime, you can see, is further along. So I'm moving it further away. My scale factor again is image over pre-image. So my image is OP prime and my pre-image is OP. And this is a scale factor of 2, so it is twice as big. If my scale factor is a number between 0 and 1, okay, if my scale factor is a number between 0 and 1, something gets smaller. So point P is right here, but you can see that P prime is moving closer to that point of dilation. And this is a scale factor of 1/2. So again, it's my scale factor is image over pre-image, all right? And if it's exactly the same, that has a scale factor of 1. That means it's actually congruent. So point P and point P prime are the exact same point. All right, so what happens when the scale factor is less than 1 and greater than 0? It gets smaller. What happens when the scale factor is greater than 1? It gets bigger. And what happens when the scale factor is equal to 1? It stays the same. All right, so if we turn over the page, use your rule to determine the location of center O used for the following scale drawings. Then determine if the scale factor would be less than 0 or greater than less than 1 or greater than 1. So I'm going to take a ruler. Let's see if I can do this. I'm going to connect the image and the pre-image. See how I did that? Okay. And then let me just connect C prime and C. That line didn't come out as straight, sorry about that. This right here is the point that I dilated it from. So this would be point O. Again, this is my original, so this right here is called my pre-image. And this right here is my image. It moved further away. If it gets bigger, is my scale factor less than 1 or greater than 1? If it moves further away from that point of dilation, then this would be a scale factor that is greater than 1. Image gets bigger. It moves further away from that point, then the scale factor is greater than 1. Scale factor greater than 1. So all I need to do to find that point is to connect the image and the pre-image points, and I have to do that twice. So again, I'm going to connect A and A prime, and then I'll do that again for D and D prime. You can do all of them, but there's no reason to do all of them. Whoops, that one's not coming out. Sometimes it draws a line for me and sometimes it doesn't. There we go. Okay, so that point of is right here at point 0. This is the pre-image, the original. The image is what it becomes. That's my image. See how the image is moving closer to that point of dilation. All right, the image gets smaller. If the image gets smaller, then it's moving closer to that point, and my scale factor would be less than 1. It has to be greater than 0, but it's less than 1. Scale factor is basically between 0 and 1. Less than 1, but greater than 0 is going to be a fraction. All right? If you have a drawing, so I've done this, all right? We could have drawn these ourselves, but I just picked out ones that were already drawn for us. What's true about the sides? The sides are actually in proportion. And we saw that on the front page, that the sides were all in proportion. If I scroll back to that first one right here, see how every single side was twice as big. I didn't have numbers on the other ones, but the sides are all in proportion. If you take out a ruler and measure them, you will see that they all are, this, whatever that scale factor is, that's how much bigger or smaller they are. What is true about the angles? Now look at these angles. Does it look like angle B has changed or angle A or angle C? Not at all. The angles are actually going to be congruent. So what is true about the angles is that they are congruent. The sides are in proportion. The angles are congruent to each other. All right? That constant of proportionality by which all lengths are scaled is called the scale factor. The scale factor, which I've been saying this, is just equal to image over pre-image. And that is definitely a question that has come up on the Regents before. It's the image over the pre-image. Okay, image over pre-image. So if I have a figure and these sides are 2, 3, and 4, and this is my original right here, and then I have a new figure and my sides are, let's say, 6, 9, and 12. Okay, it's the image. So take any, I don't care which one, take the image and then put it over the pre-image. Just make sure you're taking matching sides. So the image is 12, the pre-image is 4. So I have a scale factor of 3. Every side is 3 times as big. All right? Let's look at the problem I have here. If BC is 5 and B prime C prime is 10, find the scale factor. It's image over pre-image. Image is the one with the primes. So it's going to be 10 over 5, which is 2. Okay, and these are just things that are true about dilations. The angle measures, they stay the same. We've talked about that. If any lines are parallel, they're going to stay parallel. If any points were collinear means they form a line, they're going to stay collinear. The orientation, the order of the letters is going to be the same. The big thing is the angle measures are the same. That's the big one. And the second big thing is the distance is not preserved. The lengths of the segments are not the same, only if I had a scale factor of 1. Okay, and if I had a scale factor of 1, it would be congruent. A dilation is not a rigid motion.